Hi, my alien friends. My name is Tamara Clark, and I am here with you today live from Rosemont Hospital in La Crescenta. This is my place of work, and I wanted to take some time to explain the use and function of our anesthetic machine so that hopefully you will leave it at Pierce College opposed to taking it with you. I want to start with the gas that is used with the anesthetic machine. So this is called a compressed gas cylinder, and what is compressed in it is oxygen. Oxygen is the gas that we breathe here on Earth. There are many different tank sizes. The most commonly used is a more portable size called an E-tank. It's smaller than this one. This is an H-tank, and this is a larger size cylinder. This actually has enough gas that it supplies the whole hospital with gas. And then there's actually a larger size that is called a K-tank. Alright, so once we turn on the oxygen, you can see that the meter goes all the way up to 2,000 psi. And for this size tank, that would be an indicator that it's full. When it gets down to 500 psi, that would be when we know it's time to change this tank. Now, this is far too great of pressure to run down the line to have access to our patients. So we have a pressure reducing valve right here. And what that does is it takes the pressure from the actual cylinder and it reduces it down to 50 psi, and then it sends it up the line to be used. We don't at work have a line pressure gauge, but if we did, this is what it would look like. So you have your tank pressure gauge, your pressure reducing valve, and your line pressure gauge. And this would be reading at 50 right now if we had one. Alright, so this is our anesthetic machine. Now before I can do anything, I need to hook up the oxygen that I just turned on. So I'm going to take this oxygen line that is connected to my anesthesia machine. I'm going to connect it to the one in the ceiling. And the tank, again, is out in our treatment area. The line is run through our ceiling and it comes down here. We get to connect it, and now this runs into the anesthesia machine. The next thing I need to do is connect our exhaust or scavenging system. And I will be explaining what our scavenging system is at the end, but right now I'll just show you how I connect it. So I connect right here, hook it in, and then I need to turn it on. And that just opens that valve so that the exhaust can go through. Okay, so the oxygen is coming in here. And so at this point there's two places it can go. It can go to the flow meter, and what the flow meter does is that we turn this on and it will, based on the middle of the silver ball, it tells us how much oxygen flow, liters per minute, is being delivered to our patient. Or it can go directly over here to our flush valve. And so what the flush valve does is that when you press this button, it delivers 50 psi of oxygen through the system. And so this is, I'm going to be utilizing this later when I show you how to pressure check, but outside of pressure check, the only time you would use it would be to deliver a large amount of air into your reservoir bag at one time. But if and when you do that, you would have your patient disconnected and you would likely be blocking the tube with your hand. It is far too great of a pressure to deliver directly to your patient. So you never want to press this when the patient is connected. You would usually do this as a pressure check or to quickly get oxygen to try to flush their lungs. Okay, so back to the flow meter. Once you turn this on, the oxygen goes through the system and into the inlet valve of our vaporizer. So this is our anesthetic gas vaporizer. And this inlet, all it does is bring the oxygen into the vaporizer. So this vaporizer contains isoflurane, and it starts as a liquid, and you can see it in our indicator window right there. When you want to refill this, you would go to the fill port. You would take this off, fill up your ISO until it reads full over here, and then you would really want to make sure that's closed. Up top you can see a dial. What this dial is, an indicator of the percentage of anesthetic gas that you want to mix with the oxygen. And you can see it ranges from 0 all the way to 5. 5 would be the most, so that would be 5% isoflurane to the oxygen. So that's a pretty high rate. We would usually only do that right at time of induction to get our patient to a sleepy state. We spend most of our time between 1 and 2%. I want to also point out something else about this dial, that there's an off, which is pretty self-explanatory. It means off. And then you have 0. In theory, that would mean 0% is being delivered. And then you have one little mark and then a 1. That little mark represents 0.5, so that's a half. And then 1, and then 1.5, so 1.5, 2, 2.5, and so on, until you reach 5%. From there, so the oxygen will basically pick up the isoflurane gas. So isoflurane gas, or anesthetic gas in general, is a lazy gas. And what we mean by that is it won't move on its own. It needs its carrier gas. So the carrier gas in this instance is our oxygen. It comes by and picks up its friend isoflurane and travels through this journey with it. If we did not have the oxygen on, the isoflurane would go nowhere. We could have it cranked up to 5 and it wouldn't go anywhere. It might very slowly trickle out, but I highly doubt it would get to the patient. It has to have a carrier gas to work. So very important that the oxygen is on and flowing at a good rate for it to pick up the isoflurane and take it with it. Okay. So the oxygen picks up the isoflurane and comes out the outlet port right here and goes up this tubing, and then so now it's oxygen and isoflurane gas or anesthetic mixed together, and it's going to go 2 places. One is going to be the reservoir bag, which comes down here and mixes in, and what the reservoir bag is this gets filled slightly with air. There's a few functions for this. 2 main ones that I'll mention is one, when bagging, which means administering mechanical breaths to your patient. You would compress this as it's filled with gas, and that would deliver a rush of air to your patient. And you should be doing this about every 5 minutes under anesthesia. What that does is it takes that oxygen and pushes it into the alveoli to really give them a good deep breath. You could also use it if, say, your patient was too deep under anesthesia, you need to get the oxygen to them quickly. You could actually fill this and do the same thing. And what you would be doing is raising the level of oxygen, lowering the level of isoflurane, and it would help flush their system out. The other use of this bag is that it helps us monitor the rate of respiration. So you can see it actually swelling and depressing as the patient breathes. So it does give us an indication as to what their respiration rate is. So the isoflurane and oxygen will go down into here. And then it also will go up into the inhalation valve. Now, the inhalation valve is also known as the unidirectional inhalation valve. And just as its name suggests, it will only allow the isoflurane and oxygen to go one direction, which is towards the patient. So it comes up through here and into the patient. Now, this is the inhalation tube. It's a little hard to see, but it's the corrugated blue tube inside. So it would go down, and we'll say our patient's out here. We'll pretend it's on a table. This is typically referred to as a Y connector, and this is where the you would have a inhalation tube that's actually connected to your inhalation tube. And so it goes into the patient, comes back out. So with an exhalation on the outside of this blue tube, the air goes back through here. And at this point, I should mention, it is now our isoflurane gas. It is it's CO2 or carbon dioxide, and there may be a little oxygen mixed in there as well. All of that has been exhaled, and now we get to the unidirectional exhalation valve. Now, at this point, it can go up into our exhaust or scavenging system, or it can come down and go through our CO2 canister. And what this does is it filters out carbon dioxide. So this canister is unique because as it gets used, these little granules will turn purple, indicating that they're all used up and they need to be changed. They are typically changed about every 8 hours of anesthesia. If you let it go longer than that, you run the risk of them not working anymore. Now, it's also possible that once they turn purple, they will start to fade back to white. So relying on the purple color is not a good idea. You need to track that every 8 hours of anesthesia time, these get changed. Otherwise, you run the risk of the CO2 just going right through it and coming right back into your patient, which is very dangerous. So once they filter out the CO2, it will come right back up here, and we are back to the inhalation valve, the unidirectional inhalation valve. And again, some of it will go up here, some of it will come down into the reservoir bag. But the other thing that happens here, now this is the first cycle through on rebreathing, right? We've rebreathed it out and come through. We're going to have fresh gas, so fresh O2 or oxygen and fresh isoflurane are going to mix with the rebreathed O2 and isoflurane, go up and into our patient, and that circle happens again. So that is one, that's how this whole system works. So one thing I didn't mention is the manometer. What this does is it actually shows us the pressure of the system. So this should stay when we're doing spontaneous breathing. It will actually register somewhere between 0 and 2. This is useful for that, but it's also useful during our pressure check. I'm going to be referencing the manometer again, and we're going to have it up to 20 for our pressure check of cm of water or H2O. For us to actually do a pressure check, it's going to have to hold at 20. This also becomes useful when you're doing your check for your intubation. When you're checking the tube placement, the manometer becomes very important at that point too. All right, so I want to go through the circuits of our anesthetic machine, and I've been mentioning them a little bit. The first is a rebreathing circuit, and I have tubing. We don't use at school that often, or well, I haven't seen it at school. We usually use our double tubes, and I will actually set these up as well. But I like for work, I always use these. I like these a little bit better because I think that they are a benefit to our patients. So how this works, and I know I just described it a little bit, but when the oxygen and isoflurane come into the inhalation tube and are delivered to the patient, it comes down this blue corrugated tubing on the inside. and it delivers to the patient. The patient exhales. When the patient exhales, it's exhaling a little O2, carbon dioxide, as well as the isoflurane gas. And it's warmed because it's gone through the lungs. And so it's a little warm, and there's a little bit of moisture with it. And it runs down the outside of the tube and into the exhalation valve. But what happens to that inside tube is this warm, moist gas mixture is running down the tube, and it's warming what's inside of the inhalation tube. So I just find this a very fascinating tube, and it also helps keep the warmth and the moisture in the patient. So I find it to be a great benefit to use these. But the way the recirculation system, the rebreathing system works is that the gas comes up through the flow meter. We go in the inlet, pick up our friend isoflurane, come out the outlet, up into the inhalation valve, as well as down into the reservoir bag. We go through our inhalation or unidirectional inhalation valve in our inhalation tube. We're delivered to our patient and rebreathed, and we come through the outside of the exhalation tube. It's going to be carbon dioxide, isoflurane gas, as well as a little O2 comes into the exhalation valve. Some of it goes out our exhaust. The other portion goes through our CO2 absorbent canister, and then we come out into our inhalation valve again and get mixed with our fresh O2 and fresh isoflurane. And to be clear, what comes out here is oxygen and isoflurane to be reused, and it all goes back in again. And so that's one rebreathing circuit. I want to show you a second that I mentioned, which is, it's the exact same thing, it just looks a little different. And it's just two tubes opposed to one. I want to talk about one thing before I go through this, and that's the size of this reservoir bag. So I'm using a 3-liter bag, but there are other bag sizes available, and you determine that based on the tidal volume of your patient, times that by 6 and by 8, and the average of those is what you use. You usually round up to the larger number. If there's a huge variance between multiplied by 8 versus multiplied by 6, then you will always go with the larger, just to make sure that your bag size is correct. But I'm using a 3-liter for our demonstration purposes, but in this hospital we also keep a 1-liter, which would be for a smaller size animal, 2-liter, which is about a medium size, and then we don't really use anything bigger than a 3-liter. We just don't have that large of patients. So you would attach the appropriate size before you start your procedure to make sure that you're going to have a big enough bag to deliver the necessary volume of oxygen. So I want to talk about this rebreathing system. Like I said, it's a little bit different than the one that I did before. The only difference is this. You have 2 defined tubes. So the inhalation tube, the exhalation tube. There's no warming system here, because as this air goes in, the exhale air will come out, and by the time it goes back around, I highly doubt that it has retained any moisture or warmth. Doesn't mean that it's unsafe, it's just not an added benefit of this tubing. So again, it's the exact same system. The oxygen will come through the flow meter, will go into the inlet port. The oxygen will pick up the isoflurane, come out the outlet port, go up to the inhalation valve. Some will come down into the reservoir bag, and then through the unidirectional inhalation valve down the inhalation tubing, delivered to our patient, exhaled, and what's exhaled is oxygen, carbon dioxide. It's a little bit of oxygen, carbon dioxide, and anesthetic gas. It will come to our exhalation valve. Some will go up into our scavenging system. Most of it will come down, be filtered through our CO2 absorbent canister, and then back up to our inhalation valve will be usable oxygen and isoflurane. That will then be mixed with our fresh gas inlet here to deliver fresh O2 and isoflurane, and it will go into our patient again, and our circle continues. So that is rebreathing. What we also can use is our non-rebreathing. Now this is going to be for animals that are smaller than 7 kilograms. And I'm just going to show you how I'm setting this up. Now you notice I removed my reservoir bag because I don't need it. This comes with its own reservoir bag, so I don't need to have one on here, so there's no point in cluttering it. Now you probably saw me remove this outlet. That's because this goes directly into our outlet port. The next thing I'm going to do is, this is our exhaust. So I've got to connect this to our exhaust or our scavenging system. So how this works is a little bit simpler than the rebreathing. Now this is not a circular breathing. Exactly as it states, it's a non-rebreathing. This is for animals that are small enough, they probably do not have the strength in their lungs to actually produce an exhalation that would utilize a rebreathing. So this makes breathing a little easier. On the downside, because it's not a rebreathing, it does decrease the temperature of the patient, and it uses a little bit more isoflurane and oxygen. So it's a little bit more costly, and you really have to watch the temperature of your patient. All right, so the oxygen still comes through the same place. We're still going to use our flow meter. It's going to come into our inlet, pick up our isoflurane friend. So now we have oxygen and isoflurane together coming out the outlet through the tubing and administered to our patient. We'll breathe, we still exhale, and now we're going to take CO2, isoflurane, and a little bit of O2 right down. We'll probably go a little bit into the reservoir bag and out into our scavenging system. So again, fresh gas will come in, so fresh O2 will come in into our vaporizer, pick up our isoflurane, fresh O2 and isoflurane will travel through our tubing, deliver to our patient. With exhalation comes CO2, a little O2, isoflurane into our reservoir bag, and then out our scavenging system. Now while I have this connected, I'm going to show you how to pressure check. For pressure checks, this is going to show us if this system will hold pressure, which is very important for us. We need to make sure that we're not losing air anywhere, that something's not going to malfunction and allow our patient to breathe CO2 when they shouldn't, or enable us to, to prevent us from delivering oxygen as needed should we need to mechanically bag. So the first thing I'm going to do with this is I'm going to switch this to close. So that's going to allow me to fill this up. The next thing I need to do is seal this, and I won't seal it with my index finger. I'm going to seal it with my thumb. You can also seal it on your, I'm going to try to do that. This is difficult for me. My hands are a little smaller than what I would like them to be, so getting a seal sometimes is difficult. Okay, so I'm actually going to seal it on my palm there because I have a good seal. And I'm going to use my oxygen flush. Actually, I'm not going to use my oxygen flush because it won't do anything. I'm going to turn on my flow meter all the way, and I'm going to watch this bag fill up. And I'm going to get it nice and full. and then I'm going to hold it for 10 seconds. And actually, I'm going to make sure that's, and this actually has a hole in it, so I'm using faulty equipment at my hospital. So if it didn't have a hole, you would hold it for 2 seconds or 10 seconds. And as it is holding there, you count 10 seconds, you make sure that it's not deflating, everything's fine. When you see, yeah, that's fine, you open this valve up because you want to make sure that that works as well, that that exhaust is working, and you get that going. You deplete it again. Now, again, I'm using faulty equipment at my hospital because I don't want to use the stuff that we use for our patients for these demonstrative purposes, just in case I ruin something. So, all right. I'm going to hook up our rebreathing system so that I can show you how to check pressure check for this as well. Now I'm going to make life a little easier on me, I'm going to use a 1 liter bag because it's not as much to fill up as a 3 liter bag. So again, this becomes a little bit difficult to find the seal, but you find a seal here. The first thing you would do is close the pop-off valve. The pop-off valve is also an exhaust. It's like a relief exhaust valve. So excess gas, O2, CO2 will come out to the exhaust. This is what will pressurize your entire system. So when it is closed, it means that it will be a greater pressure on your system. You don't want this to be closed when your patient is attached unless it's for a very short time for a very specific reason. For instance, you would close it, as I'm about to show you, to inflate your reservoir bag. So if you need to do a mechanical breath for some reason, you may want to close this, fill it, and administer your mechanical breath. But generally, anytime your patient is attached to this, your pop-off valve is going to be open so that it is allowing a more stabilized pressure so that your patient can easily breathe in, breathe out. All right, so I have my pop-off valve closed. I'm going to make sure this is deflated. I'm going to create a nice seal. I'm going to do my thumb. And then I'm going to inflate with the oxygen flush valve, and then I'm going to go up to 20. And then I'm going to hold here for 10 seconds, and we'll just do a time lapse. Okay, this is 10 seconds. And now I'm going to open my pop-off valve. And you can see, as soon as it's open, that goes back to 0. All of that went out the exhaust, and this is pretty empty. So that would be how you check for pressure. Make sure there's no holes in the bag, there's nothing left on or open. And then at the end, I just want to point out again that you always open the pop-off valve. That's how you release pressure. It would be really easy for me just to let go with my thumb, and that would do the exact same thing. But you don't get the benefit of checking to make sure that this works, and that's part of your pressure check, is to open that up. The other reason is you want to open it up. It reminds you to open it. So if you're setting up for a surgery, and this is probably one of the last things you'll do is pressure check, to remind yourself to open it up, let the air go out that way, let the pressure reduce there. So 2 benefits of that. Okay, the last thing I want to show you is our scavenging system. We have an active scavenging system here, and you can probably hear it. It's a rather loud one. So what our scavenging system is that it takes all of our waste gas and it collects it in here and disposes it out in exhaust. So it is running from our surgery room through piping that comes down into the system. You can hear it running, and what I mean by that is that's actually a vacuum that's sucking it into our exhaust. We have this on anytime the anesthesia machine is on, because there's going to be anesthesia run. We need that anesthetic gas to be pulled out of the system so that we don't breathe it, and it doesn't just sit there. And so I'm done using our anesthesia machine today, so I'm going to turn it off. And the last thing that we do before we leave the hospital at night is we unplug it so that it's not a fire risk. And that completes my presentation today on our anesthetic machine. I hope that this was compelling to you, my alien friends. I hope that you learned a lot, and your decision is to allow us to keep our anesthetic machine. Thank you, and have a lovely day.